All right, so get this. Today we are taking a deep dive into Java programming.
Mm-hmm.
But there's a twist. We're going to be looking at it through this Hindi language audio tutorial that you sent in.
Oh, very cool.
I know, right? I mean, how awesome is it that you're learning to code from something created like halfway across the world?
Yeah, it really shows you how accessible tech education is becoming these days.
It is.
I mean, you don't have to be in Silicon Valley.
Right.
You don't even have to speak English to learn to code anymore.
Exactly. So inspiring. This tutorial seems perfect for anyone just starting out. Like it covers installing Java and also something called IntelliJ IDEA.
Yeah.
But before we get into all that, let's back up a sec. For someone who's never coded before,
Okay.
what even is Java? And why should they care?
Well, Java has been around since 1991.
Wow.
Which, in tech years is practically ancient history.
Right.
And it was designed to be simple, portable, and reliable,
Hmm.
which at the time, those were pretty ambitious goals.
Okay, so simple is always good. But why were portable and reliable so important back then?
Well, you got to think about it. So, the early 90s, that's when the internet was just starting to take off.
Oh, right.
Right. And Java was designed to run on any machine, regardless of the operating system.
Oh.
So it made it the perfect language for this brand new interconnected world.
So Java was like a digital pioneer.
Yeah.
Paving the way for, the internet as we know it.
Exactly. It was actually the first application language of the World Wide Web.
Really?
Yeah.
Wow. That's crazy.
Pretty mind-blowing when you think about, how much we rely on the internet today
I know.
for everything.
It's amazing to think that, you're learning a language that's had such a massive impact on the world,
Absolutely.
Pretty cool. Okay, so let's get back to that tutorial. It walks us through installing a few things.
Okay.
And there are some pretty intimidating acronyms like JDK, JRE, IDE.
Yes.
Can you break those down for us?
Yeah, for sure. So let's start with JDK,
Okay.
which stands for the Java Development Kit.
Okay.
And that's like your coding toolbox,
Yeah.
Everything you need to build your Java programs is in there.
So the JDK is where the magic happens. What about JRE?
So the JRE, or the Java Runtime Environment, that's like the stage where your programs perform.
Okay.
It gives everything your code needs to actually run.
Okay, so JDK is for building, JRE is for running.
Mm-hmm.
Got it.
Yeah.
Okay. What about IntelliJ IDEA? What role does that play?
So that's your IDE. That's your integrated development environment.
Okay.
And you can think of it as a high-tech, super organized workbench for your code.
Okay.
It's got all these features like auto-completion, debugging tools, and a really sleek interface.
Oh, nice.
Which make coding so much easier.
Oh, that's
And
awesome.
much more efficient.
Yeah. And the tutorial recommends the community version of IntelliJ IDEA.
Yes.
That's pretty cool because it means it's free, right?
Absolutely. Yeah, and it just shows that, the creators of this tutorial, they're thinking about accessibility.
Yeah.
And making sure that, cost isn't a barrier to entry for new learners.
I love that. Okay, so we've got our tool set up.
Yeah.
Now, the tutorial dives into this whole compiled versus interpreted concept.
Yes.
Can you give us the need-to-know version?
Yeah. So the main thing to remember is that Java is designed to be platform independent,
Okay.
meaning you write the code once, and it can run on any machine that has a Java virtual machine.
Oh.
And that's a big part of what makes Java so powerful.
So in the early days of the internet, this write once, run anywhere, that must have been game-changing.
Oh, absolutely. Game changer.
Yeah.
Now, the tutorial also jumps into writing a simple Hello World program,
Oh, yeah.
which is the first rite of passage for any programmer,
Right.
Have you ever written one of those?
Oh, absolutely. It's such a thrill to see the computer do exactly what you told it to do.
I know.
Even if it's just printing out, a simple message.
It's like that aha moment where you realize you're actually speaking the language of computers.
Right?
Now, one thing I notice is that the instructor really emphasizes the importance of taking good notes
Oh, yeah.
and provides a cheat sheet.
That's smart. I mean,
Right.
having good reference materials is a lifesaver when you're starting out. But I was intrigued by the instructor's advice to not rely on the cheat sheet too heavily at the beginning.
Right.
Why is that?
Well, it makes sense because you don't want to just memorize syntax.
Hmm?
You want to understand the underlying logic and the concepts.
Right. So it's learning a new spoken language.
Exactly.
Memorizing phrases from a phrase book.
Yeah.
That only gets you so far.
Right.
You need to understand, the grammar
Grammar.
and the vocabulary to really communicate.
Absolutely. And, this instructor, he seems to be encouraging a deep understanding of Java's fundamental rather than just surface level memorization. It's a really thoughtful approach to teaching, I think.
It is. All right. I'm already feeling more confident about this whole Java thing. It's fascinating to see how much thought and care went into creating this tutorial, even though it's in a language I don't understand.
Isn't that amazing?
This is so cool.
It's just amazing how much we can learn from each other, regardless of language or location.
I know. Okay, so we've covered some ground here. We know what Java is, why it's so important, and we've even got our coding environment set up. What's next on this Java adventure?
Welcome back. So are you ready for more Java? Because we're about to dive into some of the core concepts that make this language tick.
Yeah. Knowing the history and impact of Java is really cool and all.
Right.
But now I'm kind of itching to, actually understand how it all works.
Okay.
Where do we even begin?
Well, every programming language has its own building blocks, right?
Mm-hmm.
And with Java, one of the most fundamental concepts is this idea of variables.
Okay, variables. That sounds vaguely familiar, like from math class.
Right.
But how does it work in, the context of programming?
Okay, so think of a variable as a container that holds information in your program.
Okay.
You give it a name, and then you can store different types of data in it.
So it's like a labeled box where you can put different things.
Exactly. Yeah, and just like you wouldn't try to fit a gallon of milk into a jewelry box, each variable has a specific data type that determines what kind of information it can hold.
Ooh, data types. So what are some examples of these different types of, boxes in Java?
Well, you have integers, which are for whole numbers, like 10 or 25.
Okay.
Then there are floating point numbers for decimals,
Okay.
like 3.14 or 9.81.
Okay.
You also have characters for single letters or symbols,
Okay.
and booleans, which can only be either true or false.
Okay. So if I wanted to store someone's age, I'd use an integer variable, and for their name, I'd use a string.
You got it. And it's really important to use the correct data type because Java's pretty strict about that kind of thing.
Okay.
It helps ensure that your program runs smoothly and doesn't encounter any, unexpected errors.
Makes sense. So we create these variables and store information in them.
Yeah.
Then what? How do we actually do anything with this data?
Right. Well, that's where operators come into play.
Okay.
They're the symbols and keywords that tell the computer how to manipulate the data stored in those variables.
So if variables are the nouns of our program, operators are the verbs.
Exactly. You have arithmetic operators for, your basic math operations like adding, subtracting, multiplying, and dividing.
Okay.
Then there are comparison operators to check if one value is greater than, less than, or equal to another.
Okay.
And you have logical operators that let you combine conditions using words like and, or, and not.
Wow. So with operators, we can start performing calculations, making comparisons, and creating logical flows in our code.
Yes.
This is starting to feel like a real programming language.
It is. And to really control the flow of your program, you need control flow statements.
Okay.
Think of these as the traffic signals of your code, dictating which path the program should take based on certain conditions.
Okay. Traffic signals. I can visualize that.
Yeah.
So tell me more about these control flow statements.
Okay.
What are some examples?
So one of the most common ones is the if statement.
Okay.
And it basically says, if this condition is true, then do this block of code. It's like saying, if it's raining, take an umbrella.
Right. That's pretty straightforward. So what if the condition is not true? Does the program just stop?
Not necessarily. You can use an else statement to provide an alternative path of execution.
Okay.
It's like saying, if it's raining, take an umbrella, else wear a hat.
Right. Okay, so if and else statements let us create different branches in our code depending on the situation.
Right.
What other traffic signals do we have?
Loops are another essential tool.
Yeah.
They let you execute a block of code multiple times, either for a specific number of iterations or until a certain condition is met.
So if I wanted to print hello world 10 times,
Yes.
I could use a loop to do that instead of writing the same line of code over and over.
Precisely.
Nice.
Yeah, loops are incredibly powerful for automating repetitive tasks.
Right.
And working with large data sets. It's like having a robot do the tedious work for you.
Okay. I'm starting to see how all these elements work together, right?
Yeah.
We have variables to store data,
Yes.
operators to manipulate that data, and control flow statements to guide the program's execution.
Exactly.
It's like building a complex machine piece by piece.
That's a great way to think about it. And just like a well-designed machine, a well-written program should be efficient, reliable, and easy to understand.
So it's not just about making the code work, it's also about making it, like, elegant
Hmm.
and readable. Like,
Absolutely.
if someone else had to look at my code, they wouldn't be totally lost.
Right. That's why things like, clear naming conventions, proper indentation, and comments within the code are so important. They help make your code more understandable, both for others and for yourself when you come back to it later.
Right, okay. So readability is key. But we're talking about Java,
Yeah.
this powerful language that's used for everything from websites to mobile apps.
Yeah.
Is there anything else we need to know to, like, really unlock its full potential? Okay, so my brain is definitely getting a workout here, but in a good way. It's like we're putting together this, like, giant jigsaw puzzle of Java knowledge.
Yeah.
What other pieces are we missing?
Well, one of the things that makes Java so powerful and versatile is its object-oriented nature. It's
Uh,
a way of organizing and structuring code
okay.
that's incredibly efficient, and once you get the hang of it, pretty intuitive.
Object-oriented. I've heard that term before, but never really understood what it meant.
Right.
Can you break it down for me?
Yeah. So think of it like this. In the real world, we have objects all around us, right? Like
Mm-hmm.
cars, trees, buildings. And each object has specific characteristics and can perform certain actions.
Right.
Object-oriented programming lets us represent these real-world objects in our code.
So instead of just writing lines of code, we're creating, like, virtual objects within our programs.
Exactly. And to create these objects, we use something called classes.
Okay.
And a class is like a blueprint or a template that defines the properties and behaviors of an object.
Okay, so a class is the blueprint. Yeah, and the object is the actual thing built from that blueprint.
You got it. For example, imagine you're building a video game, right?
Okay.
You might have a class called character that defines like the basic attributes of any character in the game.
Right.
Things like their name, health points, attack power.
Okay, so character would be the blueprint, and then from that blueprint, I could create, like, individual characters.
Yeah.
Like the hero, the villain, or maybe even a mischievous sidekick.
Exactly. Each of those individual characters would be an object based on the character class. They'd all share the same basic attributes, but could have unique values for those attributes and even additional abilities.
Okay, that makes sense. It's like having a cookie cutter.
Yes.
You can use the same cutter to make lots of cookies,
Right.
but each cookie can have, like, different decorations or flavors.
I love that analogy. And just like those cookies, each object in our program can have its own set of actions or behaviors. We call these methods.
Methods. So is a method like a specific function or task that an object can perform?
Exactly. So going back to our video game example, our character class might have methods like move, attack, or interact.
Okay.
And these methods define what actions a character can take within the game.
So objects are the actors and methods are the verbs, the actions they perform.
That's a great way to put it. And one of the really cool things about methods is that they can take input, called parameters, and produce output, called return values.
So it's like a mini program within a program.
Yeah.
Each method has its own specific task. It can receive information and then send back results.
Exactly. Methods help us break down complex tasks into smaller, more manageable chunks,
Right.
which makes our code more organized and reusable.
Okay, I'm starting to see the elegance of this whole, like, object-oriented approach.
Yeah.
It's like building with modular components.
Mm-hmm.
You can create these reusable building blocks of code and then assemble them into larger, more complex programs.
That's the beauty of it. And as you get more comfortable with object-oriented programming, you'll find that it not only makes your code more efficient, but also helps you think about problem solving in a more structured and logical way.
So it's not just about writing code, it's about, like, designing and architecting our programs in a way that makes sense.
Absolutely. And speaking of design, there are certain best practices and conventions that programmers follow to make their code clean, readable, and easy to maintain.
Right. Yeah, we talked earlier about, like, clear naming conventions and using comments to explain what the code's doing.
Right.
What else falls under this, like, best practices umbrella?
Well, there's proper indentation to visually structure your code,
Okay.
making it easier to follow the flow of logic.
Mm-hmm.
There's also the concept of code refactoring, which means continuously improving and simplifying your code as you go along.
So it's not about writing, like, perfect code the first time around.
No.
It's about being willing to go back and make improvements.
Absolutely.
Yeah.
It's a process of refinement and optimization.
Right.
And the more you practice, the better you'll become at writing like elegant and efficient code.
It sounds like there's a real art to this.
Yeah.
Almost like sculpting or composing music, you
I
know?
like how you're thinking.
You're not just like throwing code together.
Yeah.
You're crafting something beautiful and functional.
And speaking of tools and resources, one of the things that makes Java so popular is its vast ecosystem of libraries and frameworks.
Wait, libraries and frameworks. We haven't talked about those yet. What are they and why are they so important?
Okay, so think of libraries as collections of pre-written code that you can use in your own programs.
Right.
It's like having a toolbox full of ready-made components that you can just plug into your project.
So instead of writing every single function from scratch, we can leverage existing code
Yes.
to save time and effort.
Yes.
That sounds incredibly useful.
It is incredibly useful, and frameworks take this concept a step further by providing a structure or a skeleton for building specific types of applications.
Okay.
It's like having a blueprint for a house with all the essential components already laid out for you.
That's a great analogy. So if I wanted to build a website, for example, there's probably a Java framework that could provide like a foundation for my project.
Absolutely. There are frameworks for web development, mobile app development, game development, pretty much anything you can imagine. And the Java community is constantly creating new libraries and frameworks, so there's always something new to explore.
This is making me even more excited to dive deeper into Java.
Awesome.
It's incredible to think that there's like this whole world of resources and tools just waiting to be discovered.
I know, and that's one of the most exciting things about programming. It's a constantly evolving field
Right?
with endless opportunities for creativity, problem solving, and innovation.
I feel like we've covered so much ground in this deep dive.
I know, we have.
We've gone from the basics of like installing Java to exploring some pretty advanced concepts
Right.
like object-oriented programming and frameworks.
Yes.
My brain is full.
And we've only just scratched the surface. But hopefully this has given you a solid foundation and sparked your curiosity to continue exploring this amazing language.
It definitely has. I feel like I've gained like a whole new perspective on what programming is and what it can do.
And remember, the best way to learn is by doing.
Right.
Don't be afraid to experiment, make mistakes, and learn from them. That's how you truly grow as a programmer.
So to all our listeners out there who are, embarking on their coding journey,
Yes.
embrace the challenge, have fun, and remember that you have a whole community of developers out there to support and encourage you.
Absolutely. And who knows, maybe one day you'll be the one creating those groundbreaking Java applications that change the world.
Until next time, happy coding.